In this video, we are going to discuss about the relationship between intermolecular forces, vapor pressure, and boiling points. At the end of this lesson, students should be able to explain the vaporization and condensation process based on kinetic molecular theory. Students need to define boiling point and vapor pressure and explain the relationship between intermolecular forces, vapor pressure, and boiling point. What is exactly the vaporization? Vaporization is a process in which liquid particles with sufficient energy escape from the liquid surface and enter the gas phase. Molecules in a liquid move quite freely. Each molecule possesses a different magnitude of kinetic energy. The molecules move in rapid motion and collide with one another. Some molecules have a relatively high kinetic energies. Molecules on the surface of a liquid that possess enough kinetic energy to overcome the attractive forces will leave the liquid phase as a vapor. This process is called vaporization. The similar process can be described in evaporation. Evaporation is a process which molecules escape from the liquid to gaseous state through the surface of a liquid at any temperature below the boiling point. There are three factors that can affect the rate of vaporization. First, the surface area. The larger the surface area, the higher the chances for the molecules to escape from the surface. Thus, when the surface area increases, the vaporization rate increases. Secondly is the temperature. As the temperature increases, the total number of molecules with high kinetic energy increases. More molecules have enough energy to escape from the surface of the liquid. Thus, the vaporization rate will increase. And the last one is intermolecular forces. The weaker the intermolecular attraction forces, the faster the vaporization rate. Vapor pressure can be defined as the pressure exerted by a vapor in equilibrium with its condensed phases, which is involved solid or liquid, at a given temperature in a closed system. The equilibrium vapor pressure is an indication of a liquid's evaporation rate. It relates to the tendency of the particles to escape from the liquids or solid. When the liquid molecules on the surface possess enough kinetic energy to overcome the attractive forces, they leave the liquid phase as vapor. Vapor pressure at the surface of a liquid becomes equal to the pressure exerted by the surrounding, which is known as atmospheric pressure. In an open system, vapor molecules which evaporate off will diffuse away. In a closed system, vapor molecules which leave the surface of a liquid cannot escape from the system. In a closed system, vapor molecules remain in the closed container and in contact with the surface of the liquid. These vapor molecules are in constant random motion. Therefore, the vapor molecules will continually strike the wall of the container, the other vapor molecules, and the surface of the liquid molecules. Every time the vapor molecules hit the wall of the container, the pressure is exerted. Pressure exerted by the vapor molecules above the surface of the liquid in closed container is called the vapor pressure. A substance with high vapor pressure at the normal temperatures is known as volatile. Liquids with weak intermolecular forces are volatile. What is condensation? Condensation is a process at which vapor molecules return to the liquid phase. Some of the vapor molecules may lose their kinetic energy during the collision. Thus, they do not have enough energy to remain as vapor molecules. Due to the insufficient energy, the vapor molecules will drop and reach the surface of the liquid and trapped by the attractive forces. If they cannot overcome the attractive forces, these vapor molecules will return as liquid molecules. The process is known as condensation. Now, we will describe the relationship between the intermolecular forces and the vapor pressure. A liquid vapor pressure is directly related to the intermolecular forces present between its molecule. The stronger the intermolecular forces, the lower rate of evaporation and the lower vapor pressure. A liquid with weak intermolecular forces evaporates more easily and has higher vapor pressure. For example, the intermolecular forces between ether molecules are weaker than ethanol. Less energy is needed to overcome the weak intermolecular forces in ether than ethanol. Therefore, ether is more volatile than ethanol, and it has a higher vapor pressure. How to describe the relationship between temperature and the vapor pressure? Vapor pressure is dependent on temperature. As the temperature of a liquid increases, the kinetic energy of its molecules also increases. As the kinetic energy of its molecule increases, more molecules escape the liquid phase and evaporate. The greater number of vapor molecules strike the container walls more frequently, cause the increasing in vapor pressure. The temperature at which the vapor pressure of a liquid is equals to the external atmospheric pressure is called boiling point. As a liquid is heated, its vapor pressure increases until the vapor pressure equals the pressure of its surrounding. Bubbles of vaporized liquid within the liquid rise to the surface and release as gas. In order to form vapor, the molecules of the liquid must overcome the intermolecular forces between them. When the liquid reaches the boiling point, the temperature of a boiling liquid will remain constant, even when more heat is added. A liquid at high vapor pressure has a higher boiling point. The normal boiling point of a liquid is the special case in which the vapor pressure of the liquid equals the atmospheric pressure. At the temperature, the vapor pressure of the liquid becomes sufficient to overcome the atmospheric pressure and allow the bubbles of vapor to form inside the liquid. This is how we differentiate between vaporization and boiling process. Vaporization is the change of states of a liquid into a vapor that occurring at the surface of a liquid at any temperature and pressure. While boiling process is the change of states of a liquid into a vapor that occurring on the inner surface of the liquid at a certain temperature of which the vapor pressure equalizes the atmospheric pressure. The temperature is called the boiling point. Let's describe the relationship between intermolecular forces, vapor pressure, and boiling point. A liquid molecules with a weak intermolecular forces are easily escaped from liquid surface to form vapor. Thus, the liquid is more volatile and has a higher vapor pressure. Less energy is needed to overcome the weak intermolecular forces between the molecules in order to vaporize and to reach vapor pressure equals to external atmospheric pressure. Therefore, the liquid has a lower boiling point. Otherwise, a liquid molecules with a strong intermolecular forces are hardly escaped from liquid surface to form vapor. Thus, the liquid is less volatile and has a lower vapor pressure. More energy is needed to overcome the strong intermolecular forces between the molecules in order to vaporize and to reach vapor pressure equals to external atmospheric pressure. Therefore, the liquid has a higher boiling point.